Alright, let's dive into something mind-blowing. Have you ever thought about how we're actually listening to the universe? I'm talking about gravitational waves, those ripples in spacetime caused by massive cosmic events like black hole collisions or neutron-star mergers. It's like the universe has its own soundtrack, and we've only just started tuning in. But here's the kicker. Detecting these waves is insanely tricky. It's not just about building massive observatories like LIGO. It's about controlling every tiny detail, especially the mirrors that pick up these signals. And that's where things get really interesting. Personally, I think the biggest challenge in gravitational wave astronomy isn't just detecting the waves, it's dealing with the noise. These mirrors, which are the heart of observatories like LIGO, absorb some of the laser power used to detect the waves. That creates heat, and heat warps the mirrors. Even at the nanoscale, these deformations can mess up the entire observation. It's like trying to listen to a whisper in a crowded room, while someone's constantly tapping on your headphones. What makes this really interesting is that the solution isn't some futuristic, billion-dollar technology. It's thermal imaging. Yep, the same kind of tech used in night vision goggles or home inspections. Jonathan Richardson's team at UC Riverside figured out how to use thermal imaging cameras to map these heat-induced distortions on the mirrors. By combining temperature measurements with a model of how heat flows through the material, they can pinpoint exactly where the mirrors are warping. What many people don't realize is that this isn't just a small tweak, it's a game changer. It means we can correct these deformations in real time, massively boosting the sensitivity of observatories like LIGO. And that's huge because it opens the door to detecting fainter, more distant gravitational waves. If you take a step back and think about it, this is a perfect example of how science often progresses. It's not always about inventing something entirely new. Sometimes, it's about repurposing existing tools in clever ways. These thermal imaging cameras are already commercially available, and LIGO's existing sensors can calibrate them. No need for a decade of R&D, just smart, practical problem solving. In my opinion, this is what makes science so beautiful. The ability to connect the dots between seemingly unrelated fields. Now let's talk about what this means for the future. LIGO is already planning major upgrades, like LIGO A hashtag with its mind-blowing 1.5 megawatts of laser power. But the real excitement is with next-gen observatories like Cosmic Explorer. With arms stretching 40 kilometers long, 10 times longer than LIGO's, it's designed to detect millions of events per year, peering back to the edge of the observable universe. What this really suggests is that we're on the cusp of a new era in astronomy, where gravitational waves become as common a tool as telescopes. And Richardson's team is right at the forefront, turning what seemed like a limitation into a launching pad. One thing that immediately stands out is how this research connects to bigger questions about the universe. With greater sensitivity, we can study black hole event horizons, test theories of gravity, and even probe the early universe. It's not just about detecting waves. It's about understanding the fundamental laws of physics. From my perspective, this is where the real magic happens, when technology and curiosity collide to push the boundaries of what we know. So here's my closing thought. What if the universe is full of signals we haven't even imagined yet? Gravitational waves were just the beginning. With tools like thermal imaging and the ingenuity of researchers like Richardson, who knows what we'll discover next? It's a reminder that science isn't just about answering questions. It's about asking the right ones. What do you think? Are we ready to listen to the universe in ways we never thought possible?